MiniMax H3 has been released, and it is capable of generating text to video, image to video, and reference to video. So in this video, I'll run the model on my RTX 5060 Ti 16GB to see how well it performs and generate a few videos. I'll first update ComfyUI to the nightly version. If you're using the stable version, run the file shown below to update it. In the template section, select MiniMax H3 to filter the workflows. We have 3 workflows here. These workflows require an API to run, so you'll need to purchase some credits to use them. These 3 workflows, however, run completely locally. Let's begin with the text-to-video workflow. The links to all the required files are provided inside the workflow, but first I want to check the file sizes. The BF16 model won't even fit on a flagship graphics card. You will need a workstation graphics card, so I will be using the smaller models. There are 2 types of models here. This one is the reference to video audio model, and the one above it is the first and last frame to video audio model. The same model is also used for text to video when no image is provided. Save both of these files in the Diffusion Models folder. I'll download the remaining files directly from the workflow since they are the smallest recommended versions. Even a 12GB RTX 3060 can generate videos using these large models in ComfyUI, but the generation time isn't very practical. It completely depends on your patience. The download has completed. Refreshing the page should remove the missing model error. There is already a resolution selector set to widescreen with a 0.4 megapixel resolution, which gives us an output size of 864 x 480. The video length is 5 seconds, which is the default value here. Inside the subgraph, everything looks simple. There's nothing fancy happening in the workflow. I'll try adding a Sage Attention node later, but first let's see how it performs without Sage Attention. The task manager shows that both the GPU and system RAM are fully occupied, and it is taking around 12 seconds per iteration. Since there are 20 steps, the time taken to generate a 5-second video is 323 seconds. The result looks good. The sound quality is decent and perfectly acceptable. Now I'll add a Sage Attention node to see the difference. Previously, it took around 12 seconds per iteration, but with Sage Attention enabled, it drops to about 8 seconds per iteration. The total generation time was 187 seconds, but the quality is noticeably lower compared to the result we saw earlier. I ran the same prompt again without Sage Attention because the first run is often slower due to the model being loaded into memory. So on my RTX 5060 Ti 16GB, Sage Attention 2 reduces the generation time by about 100 seconds. However, the quality is affected and the difference is quite noticeable. In this example, it failed to generate the woman's voice after the man's voice, although everything else looks good.
I am using ComfyUI and I am having a good time. I'm singing a totally different song. After this video, we won't exist anymore.
Later, I changed the prompt and tried which worked. I also tried generating a 4K image using this text-to-video workflow. I kept the video length at 5 frames. It should ideally be 1 frame, but 5 is the lowest value the workflow accepts. The generated image looks good. These are the 5 frames played one after another. I wonder what kind of videos this model could generate at such a high resolution on a more powerful GPU. Now I'm moving on to the first and last frame workflow. In the workflow, there's an option to add a second frame. Whether you use it or not is completely up to you. The prompt here is about the transparent computer mouse, so I'll load the images and use the default prompt. Inside the subgraph, there's nothing special. The workflow is as simple as it gets. The conditioning node accepts both images when they are provided. Otherwise, this workflow also works as a text-to-video workflow when no images are given. The video generation took 297 seconds, and the result looks good. With Sage Attention enabled, the generation time dropped to 185 seconds, and the result looks very similar to the previous one. The quality difference appears to be minimal. If you've watched my older videos, you've probably seen this car animation before. I originally created it using the WAN model when it was released, then recreated it with RTX, and now with MiniMax H3. The improvement in quality over the past year is quite significant. There is also a prompt guide provided. You can give it to ChatGPT or Google's Gemini to generate better prompts for your videos. I'll include the guide in the video description. Now I'll try the third workflow. The diffusion model used here is different. It's the reference to video model that we saw on Hugging Face. The other major difference is the conditioning node, which accepts multiple reference images. First, I need to check whether this workflow works properly and can generate results within a reasonable amount of time. The default prompt in the text node below uses 2 reference images. I found both images on the internet, loaded them into the workflow, and started the generation. The generation took 348 seconds, and the result was good.
To meet your maker. Get ready to meet your maker.
So I spent a couple of hours understanding this workflow. This is the reference image, and below it is the reference video of the dinosaur. Let me remove all the connections first because they can be confusing. Here I'll use 2 reference images. The first is the dinosaur itself, and the second is the background for the dinosaur. The number of available input connections here increases automatically as we start connecting the nodes. After connecting the first reference image, a new input appears for the second reference image. Now both reference images are connected. Next, I need to provide a reference audio clip from the dinosaur video shown below. The reference audio should be connected to ref audio 0. Once it's connected, another audio input appears automatically, but I won't be using it. After making these connections, this workflow becomes a reference image and audio to video workflow. The prompt contains instructions on how these 3 references should be used. Inside ComfyUI, I looked at the MiniMax video node implementation, starting from line 154. The first reference image is labeled Picture 1, and the second reference image is labeled Picture 2. The reference audio I connected is labeled Audio 1, so we need to use these exact labels in the prompt for the model to understand which references to use. Here's the prompt where I've specified how the reference images and audio should be used. Below that are the instructions describing what should happen throughout the video. During the first 5 seconds, the dinosaur from the Picture 1 walks. After 5 seconds, the dinosaur roars, using the sound from Audio 1. Finally, the video ends with the dinosaur lowering its head. In the next test, I tried replacing the dinosaur in the reference video with the blue dinosaur in the reference image. The subject image is connected to ref image 0. The video is connected to ref video 0. The audio extracted from that video is connected to ref video audio 0. Unlike the previous example, I didn't connect a separate reference audio. Previously, Audio 1 was the label for the separate reference audio connected at ref audio 0. Now, Audio 1 is the label for the audio coming from the reference video, which is connected at ref video audio 0. So even if I also connect a separate reference audio through the audio node, it will be labeled Audio 2. In that case, the prompt should refer to Audio 2 whenever you want to use the separate reference audio alongside the video's original audio. Similarly, Video 1 in the prompt corresponds to the reference video connected here. The generated result looks good. One thing worth noting is that the reference audio workflow is excellent for voice cloning. You can make almost anyone speak by providing a reference image along with their reference audio. There is also a smaller version of the model shared by a user on Hugging Face. However, it didn't perform very well in my test. That said, I only tested it once, and I was comparing it against the larger model. The demo video on the Hugging Face page looks impressive, and the model is noticeably faster than the default model I'm using. You will need to update KJ nodes if you want to speed up video generation. After updating and restarting ComfyUI, you should see these new nodes. The node in the center is new to me, and these nodes can significantly speed up video generation. Kijai has been releasing updates to ComfyUI and KJ nodes at an incredible pace. He may not need AI, but the AI needs him. He recently introduced a new node called Soul Attention. You will need to install this custom node project to get the node in ComfyUI, which can speed up video generation even further. In this example, the reduction in the iteration time is quite noticeable, and it doesn't seem to affect the video quality. I did notice that the audio quality became slightly worse after enabling it, but knowing Kijai, that will probably be fixed within the next 5 minutes. After cloning the project and restarting ComfyUI, you should see this custom node. Connect it between these two nodes like this. And this is how it should be connected in the workflow. I will do the testing using a simpler workflow so the results are easier to compare. The video resolution is set to 0.3 megapixels and the duration is 2 seconds. For this test, I'm using just a single reference image and a prompt. Inside the subgraph, everything is already connected, and I'll begin by running the workflow without any of these new nodes. The generation took 112 seconds. I'll change the seed and run it again because the first run usually takes longer while the model is being loaded into memory. The second run took 72 seconds, so this is the performance without any optimization nodes. Now I'll enable the Easy Cache node and run the workflow again. This time the generation took 53 seconds. However, note that Easy Cache skipped 7 out of the 20 steps to speed up the generation. Skipping steps generally means a loss in quality, so whether you use it or not depends on your preference. Next, I'll enable the Sage Attention node. I've already made 3 videos on installing Sage Attention, and they're very easy to follow if you haven't installed it yet. This run took 41 seconds, and the generated video looks perfectly fine to me. The quality loss we observed earlier in the text-to-video example with Sage Attention was much more noticeable than it is in this image-to-video workflow. Now I'll try using these 2 optimization nodes together. Actually, I'm not sure whether Sage Attention is supposed to be used alongside this node. I haven't looked through the code yet, so I can't say for certain. I'll make a dedicated video once Kijai is finished working on it. In the program output, Soul Attention is clearly visible, and Easy Cache is also listed. However, Sage Attention doesn't appear there. From this point onward, you'll have to experiment with these nodes yourself to see which combination works best for your workflow. I don't want to make any conclusions until I understand what's happening internally. A 4-second video at 0.4 megapixels was generated in 145 seconds. That's almost a 45% speed improvement compared to yesterday. So, that's it for this video. I hope you found it informative and interesting. Thanks for watching, and I wish you an excellent day.